Okay, so this next clip is going to be talking about vector addition and determining the components of the vector. So it's worksheet number 3, vector components, vector resolution, and vector analysis. And so problem number 2 has a graph similar to this that shows vectors on various graph paper, and the question asks you to determine the east and west component and the north and south component. And so without overthinking this too much, you simply want to look at the graph, and for vector A, it has a component, it goes 2 blocks in the east-west direction, and it goes 2 blocks in the north and south direction. And so we're told that each square is 10 kilometers. So our east-west component is going to be 20 kilometers in an east direction, and our north-south component is going to be 20 kilometers in a northern direction. When we add those two components together, we get a vector that goes in that direction. So the same thing for vector B. We can look at its east-west component, and we see that east and west, it starts here, it ends here, it goes 20 kilometers in a westerly direction. When we look at its north and south component, we see that it goes 1, 2, 3 blocks, so 30 kilometers in a southerly direction. So then if we look at problem number 4, problem 4 talks about adding the different vectors together and getting its overall displacement. So the first one asks us to add vector A, vector B, and vector C. So just like before when we were analyzing Jordy's moment, we analyzed his north and south and his east and west. So we do the same thing here. We look at the east and west components for vector A. We said is 20 kilometers to the east, and for B it was 20 kilometers in the west. So we know that vectors in opposite directions get subtracted, where one has a positive and one has a negative value. And we didn't do C, so we look at C and we see that C has a component in the east-west direction of 10 kilometers to the east. So it's in the same direction as this one, so it'll be added 10 kilometers. So the overall east and west displacement of these three vectors added together is 20 minus 20 plus 10, so it's 10 kilometers in the east direction because our east vector was larger than our western vector. If we look at the north and south components, again we have to add in C. Our C north-south is 1, 2, 20 kilometers in a southerly direction. So adding those three vectors together, we see 20 kilometers north, we see 30 kilometers south, and again 20 kilometers to the south, giving us an overall displacement of 30 kilometers to the south. So then if we back up to problem number 3, it asks us to sketch the given vectors and project the vector onto the coordinate of axes. So again, we start with our cardinal coordinates, north, south, east, and west. And it says that this angle is 45 degrees, 45 kilometers at 300 degrees. So we know from using our protractor that 300 degrees, 90, 180, 270, 300 degrees is in this direction, and we know that this is going to be 45 kilometers, this angle, It's 300 degrees. So now, using our trigonometry, we can figure out, and you say, what's our trigonometry? Well, we remember that we have our right triangle. We remember that this is the hypotenuse. This is our right angle. And we designate this as angle theta. So, looking at this angle, we know that the side opposite the angle, and we have the side adjacent to the angle. And knowing those three things, we can use our mnemonic SOHCAHTOA to determine things about a right triangle. So how does that help us on here? Well, when we use our cardinal directions, we can make right triangles, and we can use our trigonometry functions to determine that. So we can determine that our component in the x direction, or our base here, is going to be, so it's in the x direction, it's going to equal our hypotenuse times the cosine of angle theta. And how do we determine that? We look at our angle theta, and we see that we're looking for the side opposite this angle, and we can use the cosine. So we were given the angle is 300 degrees, so the cosine of 300 degrees, we punch that into our calculator. Sorry, Charlie, just have to do it that way. And we multiply that by the hypotenuse, which was 45 kilometers, and that will give us 23 kilometers will be this component. We also need to know how far down our triangle goes, so how far in the y direction. And so we know if we're looking at our y direction on our using our trigonometry functions, we have already the hypotenuse, so now we're looking for the side opposite of that. So we're going to use our sine function, and so once again we'll have our hypotenuse times the sine of our angle, and this will get us negative 39 kilometers. Why is it negative? Negative, again, in physics indicates a direction, so it's in a southerly direction. Either way, 39 or negative 39 negative 39 kilometers to the south. Either one of those would be good for this one. So hopefully that helps you conquer worksheet number 3.